Hey guys, good evening. Good evening, everybody. Good evening. Good evening. I hope I'm clearly audible. I guess I'm audible. Somebody can respond from the other side. Good evening, all of you. Good evening and welcome to Cat Ninjas. Let's get started. I guess I must be audible, I guess. Good evening and let's get started. Shall we? I think we are live. Let me check if there is any issue here. All right, welcome. Let's get started. Welcome. Good evening to all of you. Warm welcome to Cat Ninjas, and we are continuing our discussion on numbers. I told you in the previous lecture that probably it would make sense if you read a little bit about the divisibility and the LCM and HCF. Maybe I will spend a short amount of time today. So let's talk about the divisibility. I don't speak about the rules, etc., etc. What are the divisibility rules, all that stuff. So I will pick up questions based on the lines of CAT, ZAT, and IIFT which appeared based on divisibility. Of course, there are types of questions which appeared. I'll just pick one particular variety type and then we will kind of discuss that particular variety, right? That's what we kind of do. Can somebody confirm from the other end that, okay, I'm clearly audible, guys? Am I audible? Good evening to all of you. Am I audible the other end? Is there anybody in the discussion? Is my window frozen? Absolutely no idea. Okay. All right. Now, Ankita is saying that yes. Sonakshi is saying clear. Sarthak is there. All right. Srishti is there. Good, good. All right. All right. Fine. Fine. All right then. Okay, you guys meanwhile settle down. Okay, Vanya is there. All right. Prashant joining in. Good. Okay, guys. Good. That's nice. That's nice. Okay. Meanwhile, let others join in. You guys keep your book ready. Keep your pen ready, and let me do. Let me meanwhile introduce myself. I'm Belvi Srinivas, as you most of you know because you are following me quite regularly. If there are any new learners, so I've been working in this industry since 2007. That's about 14 years now. I worked in various capacities, both as a trainer, training the students, training the faculty members, and also in the management. Contributed something towards the management, the course designs, etc. And also, I have developed skills in training the students, especially in the areas of QA, DI, and LR, and also in bit of counseling with respect to various aspects of your preparation. Yeah. And if anybody would like to have short discussions or any doubts, etc., etc., you can always join this particular group. And there some posts you can post there, and we can get on with some short, brief discussions. This is a Telegram channel. You can join into that particular Telegram channel just in case you want some further discussions, etc. Right, let me do quick announcements. As most of you are aware, there are two variants of subscriptions available with Unacademy. One of them is called Plus, the other one is Iconic, represented by Star. So as you know that Plus gives you the structured courses with respect to the various areas of QA, DI, LR, and Verbal and RC. GK, even including the GK, etc. It gives you various aspects and different trainers launch different kind of courses at different difficulty levels, right? Some of them are very foundational, some of them are intermediate, some of them are advanced, right? Various kind of courses are launched. That's what we mean by the structured courses. Along with that, yes, you do get certain quick study material, access to weekly test, and a few other live and as well as the recorded classes which happened in the past, just in case you want to do those courses as well. Yes, Iconic in addition to this gives you it also facilitates you to have one-to-one interactions with some of the mentors, be it with respect to the college guidance, which college to apply, and what should I fill forms, some of the questions appearing in the college admission forms, or it could be with respect to the test analysis scores are not improving, how we can improve a score in particular area where you are faltering. Such discussions, you can have discussions with respect to doubts, with respect to study plan, which or whatever be your area wherein you require one-to-one discussion. That is what Iconic gives, the facilitates you to have those discussions. Yeah, these are the nominal subscription prices, and you get 10% discount on these prices if you use any of the educator code, including my code, which is Belvi 100. Yes, so you have certain offers going on till 30th. That's about if you buy a 2 month subscription, 4 months free, 2 months free, and 1 month free, etc. If whatever suits, you can look into that. And yes, if you're especially preparing for CAT 21, I would rather suggest go for a 6 month subscription, because the coming months, October, November, December, Jan, up to March, is going to be pretty crucial. You'll have a lot of application forms to fill, a lot of consultations with respect to the score improvement, and etc. All the study plans, all that stuff might come in the picture. So that's about. So how many of you have taken the mock test yesterday? I want to know. So whoever is attending this particular lecture, I keep telling you guys that hey, Sunday you should write a test. Doesn't matter about the score, but first I want you to create that habit. Every Sunday you should be taking a test, not watching others taking a test. You should be taking a test. I would like to know how many of you have taken the test. Yeah, scores doesn't matter. How many of you have attempted the test? Okay, Mohit has taken. Okay, whichever test, right? Whichever test. Only two of you, Mohit and Sonakshi. That's it. It's poor, guys. It's very poor. Despite repeatedly telling almost every single day, I keep shouting, saying that, hey, you guys have to take at least two tests in a month and one should come on Sunday. And there are only two of you. Sonakshi has taken the test. Okay, one of you also did. Yeah. Okay, okay. Doesn't matter which platforms, all that is later. You write it first. It doesn't matter where you take a test. Right? I never asked you those questions, what you do, where you do, but do. Right? Do. Follow something. Okay. Ankita also has written good. Oh, that's good, Mohit. That's good, I guess. Yeah, that's good. Congratulations. That's not bad at all. That's good. Yeah, right. Okay, okay, fine. This brings count to what, about five? Five is still a small number. I don't know how many of you are there in the live discussion. So if only five of you are there and all of you have written, it is good. Uh, okay, okay, okay. Kishan also has written. That's good. That's good. That's a later discussion one. Yeah, don't worry. Don't worry. That discussion we will take it later. I didn't ask about your percentiles and scores because that's another discussion altogether, right? So if we get into it and all of you start posting your first, you start with overall cutoffs and then you will start posting sectional cutoffs. That would be a crazy discussion. That's another thing. We'll park that for another day. If you want, we will take it on one of the days, right? That is another discussion, and that is nice to be done one to one, right? That doesn't make sense in a group because we are all different, our skill sets are a little different, the way the skills mature is also a little different, right? So I understand all this. So in a group those things actually don't make too much sense. Okay, Rishav, have you written the test, man? You're logging in now, but have you written that mock yesterday? Yes, no? If no, then you have to drop off from this lecture. You should write test and then attend. Anyway, I'm kidding. Don't worry. Yeah, I'm hoping that you have written the test. Great. All right. So let's go here. So tomorrow, the day after tomorrow, I guess 29th. Yes. All right. There are certain batch launches. And if you are on the platform, yes, you can try and consider if any of these batches. There are some of the finest educators. You can try and check if something matches there. All right. So this brings us to the today's discussion. As usual, I'm not going to do the part of the basics, right? So I'm not going to discuss the basics of divisibility rule, etc., etc. And don't panic if anybody is preparing for CAT 22. So we will have sufficient time. We will do it. So Ninjas 1.0 is for CAT 21 prep, basically because they are about 60 days to go. So we are doing a little bit of impactful. I'm assuming at this point in time we all will be comfortable with divisibility rules, how it came in the picture, where it came in the picture, the whys and wheres of it. So knowing that, okay, a little bit of understanding of divisibility, let's now get into the application side of it. And technically, I'm pulling out the applications from CAT, XAT, and IIFT kind of perspective. The kind of questions that we are looking at, if you are looking at SNAP or exams like NMAT, I don't think it is not likely, right? It is not going to be likely. Therefore, I'm not talking at that level. And even from the CAT perspective, I'm not talking at the foundation level, etc. I'm at least looking at the intermediate level of the discussion. Right, let's unleash ourselves. What I do is I will give a reflection time. Even if you are not able to get to the answer, etc., don't worry about it. It's simply built. Divisibility is what I'm going to start with. Pretty simple skill. Let's start there, and let's start with one of the very simple questions to start with. I will give about a minute's reflection time. Everybody pull out your copies, book and pen, and start working on the question. I don't want anybody passively looking at the screen. Right, when it is your time, you got to use your time. Go ahead, guys. Here we start with a question. So if you want a little more time, I will extend it, but get started. Everybody get started. Take your books, take your pen. No passive visual, no passive watching. Yeah, good evening, Mr. Anurag. Get to working, man. Get to working. Okay, I will extend by a little more time. It's okay because everybody would have a cold start in the beginning. So warm up. Just to warm up, I'm just giving a little more time. Because generally, the first question when we do, we all have a cold start, including me. It's a human trait, common human trait. Yeah, I'll extend a little bit so that start thinking your divisibility, etc. representation. Use division algorithm. Hmm. All right, do it with me, guys. Do it with me. Is the screen frozen? Am I not able to see your answer, or is it really, really cold start today? Weather is also cold, I guess. Weather is also cold. Can you guys put the temperature at your places? What is like night temperature is reading like? I think it's a very pleasant weather these days. And anybody affected by cyclones, I don't know from where you guys are logging in. Leave this question, we will do that question. Can you put how the weather there? Pleasant, cold, warm? Can you guys put in there, and you can put your place name also. Can you put the state or district headquarters kind of from where you guys are logging in? Whoever is comfortable, you can put the place name and how the weather is. Oh yeah, okay. One is from Pune. Pune is cold. Yes. Oh, it's hot in North Srishti. Okay. Which place? Which place? Sonakshi, which place? You guys can just put the place there. Boy, Delhi is always hot. Okay. Okay. Humid. All right. Patiala is humid. All right. Guncha, Delhi. Awesome. Awesome. NCR. Oh, so many guys from Delhi NCR region. Is it Mohit, Guncha, Sarthak? All right. Prashant, Bihar. All right. Okay. How's the weather there in Bihar? Ahmedabad, 28. 28 is pretty pleasant in Ahmedabad, Nazia. Right? Yeah. 28 is a pleasant weather. So I think it witnessed heavy rain someday, some last week, I guess. So because of that, Kamlesh 32, 32. Okay, Delhi is 32. Okay, Nachiket, Karnataka. Okay, which place in Karnataka, Nachiket? Okay, nice, good. So I kind of got the weather report majorly from north, right? Majorly from the the upper portion. So I didn't find too many people except Nachiket saying that Bangalore, Varanasi, Ankita Varanasi. All right. How is the weather there? 32. Okay. Hmm. Yeah. Actually, one yes, you listed the lowest possible number. Right, good. All right, guys. Fine. Anyway, so whole of India looks like we are witnessing the pleasant weather. 30s are fine. All right, 30s and 20s. It's pretty good. Yeah. Okay, in between Sonakshi gives answer also. Yeah, fair enough. Good. Let's take a look at this. N and D, let's take an approach. Let's see. They say these questions. Today I'm going to spend some time on divisibility algorithm, right? Divisibility algorithm. And since we already did some remainders, it's kind of clear to us and we can use some of those properties as well. So if you look at it, hey, what is the theme that I'm picking today? From what perspective I'm talking today? Divisibility algorithm. What is divisibility algorithm? If there is a number, and if there is a divisor, of course, there is some quotient and there is a remainder, right? So this is the algorithm I'm talking about. So how do we represent it mathematically? We all know that this can be written as n is equal to, this can also be represented as number is nothing but divisor into quotient plus remainder. This is the division algorithm, right? This is the division algorithm. Today I'll be talking about the applications built on division algorithm. Oh, so many questions come on division algorithm, but somewhere all right now the people kind of tend to ignore this. It's such a simple algorithm, but some fantastic questions are created based on this algorithm. I will spend little time on this, right? I will spend little time based on the intermediate kind of levels question, intermediate level questions asked based on this division algorithm. Fine, let's take a look at this question. N and D are, some people represent like this also. There is nothing wrong. In some of the classes, the division algorithm we represented like this also. When the quotient was not important for us, we represented like this. N divided by divisor leaves a remainder R. Whenever we represented like this, we said that, hey, quotient I am not interested, right? Quotient I am not interested. If quotient also has to be brought in, then you better write it like this, right? Divisor into quotient plus remainder. That's it. Nothing wrong, because when we were doing remainders chapter, if you remember, when we spent sufficient time on remainders, we used to represent certain thoughts like this. That was a cautious decision because we were least bothered about the quotient. If you think that somewhere the quotient is also kind of playing a role, probably I may have to pay a little bit of attention to quotient, then you better represent it like this, right? Which way to represent, that depends on, is quotient, would you like to represent a quotient? Do you think quotient is playing a role in it? Then you can represent this thought, right? Either ways the thoughts are fine, or combination of the thoughts are also fine. Let's try and explore this quickly. N and D are natural numbers. Good. N is divided by D. The remainder left is 66. Now, which way to write? That's your choice. Can I write like this? This is also fine. N divided by D. The remainder is 66. If this does not help, I will quickly rewrite it later as N is equal to D times of quotient plus 66. Two ways. Both the things come in my mind. That's my point. If this representation also pops up in my mind, this also pops up in my mind after reading the question. If one side is not helping, I will try and figure out from the other side. That is the whole thought behind this. Okay, two thoughts. So let me start with the first thought. When 2n is divided by d, the remainder is 9. But I already know, hey, when 2 times of the number is divided by d, the remainder is also supposed to be 2 times of this. We already kind of discussed this in one of the remainders chapters. If you have not taken as a part of this number series, the whole list should be there in the description. Please go to the description and take a look at some of those lectures. So the very first lecture on remainders, take a look. That's where I discussed this, right? Yeah. Twice the number, the remainder also should technically get doubled, which means I'm expecting 132. I'm expecting 132, but what author is saying, hey man, it is not 132, it is 9. Okay, author is saying it is 9. I'm expecting 132, but this fellow says that it is 9. Okay, in the sense, what happened? If 132 is too large, if it is greater than the divisor, I provided probably divided by divisor, and I might have written this as 9. From here, I will get the dummy value of the divisor. One of the values of divisor should be 132 minus 9, which should be 123. Okay, give me a confirmation this 123 is clear to you guys, because I have to understand to what extent I should explain. 123 is clear. One of the values of divisors. I'm not saying that this is the divisor. I'm saying one of the values of divisor at this point in time is 123. That's clear. That's clear. Okay. Okay, right. Okay, fine. Listen. So what are the other values of divisor? The other values of divisors are factors of 123. Other values of divisor, if you want to know one of the values, the on the face of it, one of the values of divisor is 123. If I would like to know what are the other values of divisor, it should be factors of 123. Okay, what are the factors of 123? Sure, 123 itself is a factor, and then 41 is a factor, then 3 is a factor, 1 is a factor. Now these are the things which turn in your mind, out of which you discard that, hey, 1 cannot be the value of divisor. You are talking about the divisors can be, 1 cannot be the divisor. Why? Because 66 is the remainder, man. What is the meaning of this? If 66 is the remainder, D is greater than 66. Simple. Because when the number was divided by a divisor, the remainder was 66. What does it mean to us? It means that the divisor was greater than 66. So therefore, 3 cannot be the divisor, 41 cannot be the divisor, 123 is the divisor. So in the sense, the moment I read this question, project these two pieces of information, this is what flashes in my mind. You don't have to necessarily write to discard the things, etc., because the moment you have 123, you know the factors of 123 coming into your mind, you say that, hey, and this 66 also comes into your mind. The moment you read this information, you know that the divisor has to be greater than 66, no doubt about it. And then you say that all these things automatically get discarded in your mind. They flash in your mind and they vanish. They have their death also in your mind. So therefore you say that the only value the divisor can take is 123. Great. All right, coming to the question. Find the remainder when 5 times of the number is divided by d by 3. That is what author is interested in. Okay, having known the divisor, okay, what is d by 3? What would be d by 3? Therefore, let's understand what is d by 3. 123 divided by 3. Why 123? That is what we said. The value of divisor is 123 divided by 3 is 41. Great. What was my number, by the way? What was my number? My number was divisor times of x. All right, divisor times of x plus 66. I mean, I'm talking about this. I'm just writing it in the alternate position. My number was divisor times of x divided by 66. Great. But then author said that, why don't you divide this by d by 3? Why don't you divide this by d by 3? In a sense, he said that, hey, it's not by d, man. You have to this you divide. What was the divisor here? 123. But author said that it is not 123. Why don't you divide by 41? I will first divide this by 41. Therefore, I could kind of say that when the number is divided by 41, what is 41? Divisor by 3, the remainder is 5. I simply divide this by 41 because this number, when I divide by 41, the remainder is 0. You may wonder why remainder is 0. Isn't it d 123 then? If d is 123, 123 divided by 41, remainder is 0. Therefore, you are now saying that when the number is divided by 41, the remainder is nothing but 5. From where I am getting this 5? From here. From here. Good. So therefore, 5 times of the number. Now from here, 5 times of the number divided by 41. The remainder would be, sorry, 25. Sorry, 25. 25. Therefore, 25 into 5, which would become 125. 125 is greater than 41. Therefore, I would divide by 5. I will say the final remainder is 2. Why? 41 into 3. What is this number? 25 into 5 is 125. 41 into 3 is 123. Therefore, the remainder is nothing but 2. Any confusion? Anybody here? Anybody? Any confusion? This question is simply built on division algorithm. Which way to represent? That doesn't matter. Either you can represent like this or you can represent like this. Which way you represent doesn't matter. But did you follow any part I need to explain? This is the first question. Any part I need to explain? Is this clear? If it is clear, quickly put it as clear because we have few other questions to do on the same algorithm. Clear? Okay. Hmm. Yeah, as many as you could respond. That always helps us to move a little faster and better, right? That will always help us to move a little faster and better. So as many as you could respond to it, respond and always stay on live. If you are behind, then you will be answering pretty late, right? Stay a little bit onto the live so that it is easier. Any portions are missing, you can always little bit go back, right? Because I'm anyway repeating it a couple of times so that you all can kind of catch up. So no point that already you kind of lag behind. Keep video always onto the live portion. Yeah, let's come to the second one. Let's come to the second one. Try this question. Everybody try this question. Try and close it in about 2 minutes time. 2 minutes is good time. Do it slowly. No hurry. 2 minutes is a good time to do this question. All of you try this. Give a sincere attempt. Good. Nice. Very good. Very good. Yeah. Yeah. That's right. Most of you answered it as 49. 49 is the right answer. That's right. Right. That's good. Very good. Very good. Simple division algorithm, right? Yeah. N and D are natural numbers. When n is divided by d, I can write my number as n is equal to d times of quotient plus 30. That can be my another way of writing the same n could be I could say n is equal to d times of 9d. It's a 9. I can write it like this. Divide by 9d is a 9dy. I can write y is a quotient. I can also rewrite this as d times of 9y. Both are same, right? Both are same. This gives me a remainder of 49. This gives me a remainder of 40. It's the same number. It's the same number. No 3 times of number, no 4 times of number, nothing like this. I will simply put a bracket. I can put a bracket wherever I want. It's the same number. I'm just putting this particular bracket like this. So I can equate these two because both are same numbers. A number can be expressed like this, the first equation. The number can be expressed the other way around as well. Therefore, I can equate a d times of x plus 13 is also d times of 9y plus 49. I didn't do anything. I just put a bracket. Where you want to put a bracket, how does it matter? It is the same equation. So therefore, just suitability perspective, just to understand it better, I'm putting the bracket like this. Sure. So then from here, I would say that hey, d times of x minus 9y is also, I'm just taking these d's to the other side, this 13 to the other side. So thereby it becomes 36. D times of something is equal to 36. Hey, what is my d here? My d is a divisor. What is my d here? My d is a divisor. What is my divisor? My divisor is greater than 13. Look at the first statement. The remainder is 13. What does it mean? My divisor, from very my first statement, I know that my divisor is greater than 13. Right? I knew that the moment I read the first statement itself. Therefore, 36, my divisor can be 36 itself. Why? Because this can be 36 into 1 is equal to 36. X minus 9y works out to be 1 because the x and 9y are nothing but the quotients. Therefore, it works out to be 1 there. So, the d can be 36 or the factor of 36. What is the factor of 36 greater than 13? 18. Other factors don't work. You may say that 9 is also a factor, sir. But 9 doesn't work because I know my divisor is greater than 13. Only two values of divisor. Either it should be 36 or it should be 9 or it should be 18. One of these is the values of the divisor. Fair enough. So let us take the smaller of them because answer cannot be determined based on which one I use. I use the case one or I use the case two. This can be the case one or this can be the case two. Let me use the case two to start with. Smaller of the two. Let me use the case two to start with. Okay. Now what did he say? He said that hey, why don't you divide the same number by 3D? I will take this as my reference point. I will take this as my reference point. Author is saying that please divide this by 3D and tell me the remainder. What is the minimum value of 3D? The minimum value of 3D is 18 into 3 because the value of D is 18. 3D I am talking about. Therefore, 18 into 3, which is 54. Okay, so this when divided by 3D, remainder is 0. From here, the remainder is 0. Why? Hey, there is a 9 here, D here, 3D. Therefore, already the remainder is 0. So I will divide this by 3D. My one case of 3D here is nothing but 54. 49 divided by 54, the remainder is 49 itself. Or you may say that, hey, what if I take 36? 36 into 3, already that would become 108. Doesn't matter. For 54 itself, if I'm getting 49. For 108 also, I will get 49. Answer is consistent. Although D has two values, unlike one value earlier, here the D has two values. Still, my answer is consistent. Therefore, I say that here my answer is 49. Is it making sense? Everybody clear? So there is a consistency. Although there are two cases of values of D, answer remained consistent. If there is an inconsistency, then the answer becomes cannot be determined. But here it is consistent. Answer is still consistent. Although there are two cases, it is consistent. Comfortable, friends? Everybody comfortable? There can be inconsistency also at times. There can be inconsistency. But here in this case, it is consistent. Okay, change this number 49. Alright, if I change this number 49 to 59, answer becomes inconsistent. Just change this 49 to 59, answer becomes inconsistent. Why? For 54, the remainder would change. For 108, the remainder would change, right? The inconsistent. I mean, of course, these values also change. There are a lot of dynamics which will happen. I'm just saying that at times it can be consistent, at times it can be inconsistent. Because all over, the moment I change one value, the most of it keeps changing there, right? Most of it keeps changing there. Repeat. What I should repeat here? Somebody has logged in as BADASS. Which part I should repeat? What you didn't understand? Can you be a little more specific? Which part you didn't understand here? Rishik, what you are trying to ask, how many ways solve this sum? There is only one division algorithm. What is how many ways? How 18 into 3 came? All right. How 18 into 3 came? Because author is saying that divide n by 3d, no? Divide n by 3d. Divide n by 3d. So we said that the d value can be either 18 or 36. Either 18 or 36. I took 18. I will take 36 also. Both I will try. Rishik, I told you two ways, right? How you can represent n divided by d, the remainder is 13. This is one way. The other way is n is equal to d times of some quotient plus 13. These are the only two ways representing the division algorithm, right? So here what? I don't mind quotient. Here what? I mind quotient. That's it. That's it. That's it. There is nothing. What big deal about it? So why there is a fuss? What big deal about this? We make fuss if the things are pretty complex, right? So these are the two ways. Which way to represent depends on is Q required, is Q not required. That is it. That's all the decision you should make, right? That is all the decision I should make. Okay. That's all the decision. Yeah, no big deal about it. So when I represent in these two styles, when Q is important, when Q is not important. Important in the sense, do I need it? Don't I need it? Do I need it? Don't I need it? Okay, now Anurag, you are saying that what if I divide this by 3D? No, make it judgment, make the right judgment. That is called wrong judgment. So when it is easy to deal with the second equation, why you want to complicate it by dealing with the first equation? That is called as making a mountain out of a molehill. Right, that is what we are trying to say. You need to be judgmental when there are two equations. Of course, that is what the logic is all about. Which one I should consider? You should see it. You can't say that I want to make a mountain out of a molehill. That's not the right way of dealing with it. That's what we did even in fact of our remainders also. Sometimes we worked with positive remainder, sometimes we worked with negative remainder. Towards the end, we came and gave the answer as the positive remainder. Why did we do sometimes positive, sometimes negative? Make the things easier to arrive at the answer option. Why complicate it? It is not that from here we can't arrive. It will take definitely into four times the effort. Into four times the effort. Naturally, it will take that kind of effort. Right? Because you are now trying to create a mountain out of molehill. That's a whole thing. Right? Huh? I hope you understood my message, Anurag. Is this clear? When there are two propositions right in front of you, deal with the easier one. Easy thing first. Yeah, that's a thing there. That's it. It's nothing like first thing first. You wrote this first. So mind always says that first thing first. But when it comes to exam, I always said easy thing first. It is never about first thing first. It's always about easy thing first. Right? I remember while I was writing CAT in 2013, my first question in CAT 2013 was on logarithms. Right? I remember. Right? First question was on logarithms. And I was totally foxed by that particular question. What is this kind of question? Right? I didn't answer. There were two parts to that particular question. There was a part one and part two, right? So I came back and answered one part. Part one I answered, part two I did not answer. Then I came back. See, the questions what you don't solve, it's a quant section I'm talking about, QA section of 2013 paper. I just came back and just Googled it. It was a Hungarian Olympiad question. It was a Hungarian Olympiad question. Difficult one, man. It was a difficult one. Hungarian Olympiad 1961 paper. I don't remember either 1961 or 1969. I just remember that one of those edges. In all likelihood, I think it is 1969. If I don't remember it right, I think 90% it's 1969 Hungarian Olympiad question paper. There were six questions in that Hungarian Olympiad paper of 1969 Math Olympiad. So it was one of those questions. Now it was directly printed word to word as it is. They didn't even bother to change the variables. At least they should have minded to change the variables. That person, whoever has said that particular paper that year, he didn't even bother to change the variables. And the second question was another Olympiad question in 2013. I said that leave them. So therefore what? It is never about the first question first. It's always about the easy question first. The third question made some sense. In fact, the first two questions were based on the same information. Third question was also already knows one of the Olympiad questions, but it was okay to deal with. Then the fourth question was the first question I kind of attempted because it didn't make sense. It didn't make sense. Right? Therefore, it's never about the first question first. It is always about the easy question first. Hey guys, message loud and clear. Sometimes you get Olympiad questions cut paste as it is in CAT. As it is cut paste in CAT. As it is cut paste. I'm not kidding. All right, that's what the reality is. All right, yeah, let's go on. Let's go on. Okay. I just gave my reference of what happened with me. I will tell more often rather than trying to tell what happened with somebody else. Okay, because enough of things happened with me as well. Okay, let's go in here. Hmm. Right, let's go here. Right, okay, let's go in here. Solve this 2 minutes. All of you make an attempt, guys. All on division algorithm. Beautiful question on division algorithm. Hmm. That's right, Anurag. Solve this. All of you solve this. Well, guys, let's do this. Let's do this. What does it say? A number when divided by 29 leaves a remainder of 3. If the same number when divided by 87 leaves a remainder of R. All right. The question is good, good. I'm getting, yeah, most of you answered it and the answers are right. Right. How many possible values can R assume? Right. Okay. A number when divided, this number when divided by 29 leaves a remainder of 3. If the same number when divided by, you can write it like this as well, n is equal to 29 times of x plus 3. If the same number when divided by 87, what is this 87? Or 87, 87 is 3 times of this number, right? 29 into 3, that's the first reflection, that's the first thought of reflection, 29 into 3. Right, 29 into 3, therefore n is equal to 29 3y. 29 into 3, that was your divisor, say the quotient is y. This leaves a remainder called R. That's all I'm trying to write here. 29 divisor has become 3 times. I will just put a bracket here for easier understanding. Just like one of the questions that we solved, I will just put a bracket here. Technically 87 is nothing but 29 into 3. That's one thought which should just come into your mind. That's it. Hey, 29 and 87 looks like these divisors, looks like divided. The divisors are just connected in the form of into 3 kind of. That's all which has to come into your mind and the problem is over. Right, therefore 29 into 3, this is what is 87 here, but what I'm trying to do, I'm just trying to put a bracket here and these two numbers are same. Therefore you are trying to say 29x plus 3 is equal to 29 times of 3y plus r. Keep r separate, keep r separate. Therefore you would say that r is equal to, therefore you would say that r is also r is equal to 29 times of x minus 3y plus 3. Nothing I did. I shifted everything on one side and I kept r on the other side. That's all I did. Okay, therefore, all it now r is equal to, if this is 0, 29 into 0, then the r value would be 3. That is one of the values r can take. Because why can x minus 3y be 0? Why not? Other quotient can remain same. Quite possible. Therefore, r value can be 3 itself. Now, what is that you are dividing by 87? Listen, all at 87, and hence r should be less than 87. Why? Because your divisor is 87. When your divisor is 87, the remainder is r. Remainder has to be necessarily less than 87. That's the point. Okay, therefore 29 into 1 plus 3 would work because the outcome on this particular number is nothing but 32. Is this 32 less than 87? Yes. 29 into 2 plus 3 will work, right? Because that is nothing but another 29 added to this 61. 29 into 3 anyway will not work because 87 itself is 29 into 3. There is no point talking about it. And hence you say that there are 3 values it can take. Pretty simple question. All you got to realize in this question was what? 29 and 87 were connected in the form of into 3. Point clear? Simple question. Clear, guys? Yes or no? The reflection thought was only with respect to 29 and 87. All clear? Yeah. Hmm. Be attentive to numbers. Be attentive to numbers. Watch out. Observe the numbers. If you observe the numbers, you will get them. Right? Huh? Be attentive and observe the numbers. Take time. That's the reason I also give that time. All right. Take time. Observe those numbers. Yeah. Here comes a beautiful question. Hmm. I expect that everybody would solve this. Yeah. What is that you are asking? Is it remainder should be less than remainder? What is that question? B.A. Das. Remainder should be less than remainder. What is that question? Yeah. I didn't understand. Try to reword it. Of course, yes. Of course, yes. Class 4 student will tell you this, isn't it? Why you are getting such doubt? Are you trying to quiz me or you're really confused? Think about it. I'm not kidding. I'm serious. Class 4 student will be very clear about that fact. Confused, yeah. Now there is a clarity, remainder must be less than, okay? Yeah. Hmm. Good. Why only Sonakshi and Aradhya answered this question? Okay. Okay. Yeah. Fine, guys. Let's take a look. Let's take a look. Again, division algorithm simply based on I already conditioned your mind. I'm going to quiz you on good. Yeah, last answered Mohit, Prashant. Good. This is impressive. Varshini got the answer. Nice. Prashant, why C? It should be B. B should be the answer, not C the answer. I think you might have made somewhere the calculation error there, right? Okay, let's take a look. Again, division algorithm, just I already conditioned it. Just pay attention to division algorithm. Some of the beautiful questions can be answered, just that people just fumble about it and they create confusion. Yeah, a natural number P when divided by another natural number D leaves a remainder R. Okay, P is equal to D times of X plus R. If 5 times of P when divided by 2D, okay, 5 times of P when divided by 2D, I deliberately write like this. That's one technique you are learning today. That's it. So try to write like this. If there is a D, keep the D outside and try to write it. Although we can write it as 2D times of Y, I'm saying that rather than writing this, learn to write like this. The moment you learn to write like this, automatically the answers will come faster. Right? That's all the small change. Because more often people write it as 2D times of Y. The first question they would have written this as D times of X. Second question they will write it as 2D times of Y. That creates a confusion. Bracket you can put anyway, the value is 2dy and then some remainder. Why don't you write it like this? If you write it like this, it becomes faster. So if you look from the first question, this is what we did in 3 out of 4 questions by now, right? Yeah, D times of 2y. This is where you put a bracket. So that gives me a remainder of 3r. Fair enough. Subtract, reduce it, reduce this question, reduce, subtract the first equation from the second equation. See, whenever you have two equations, add, subtract, equate, do whatever. I can't equate because p is on one hand, 5p is on the one hand. So earlier I equated because it was the same number. This time equating doesn't make sense because there is one hand p, on the other hand I have 5p. Therefore, naturally I will try and subtract or divide things like that. Subtract, and I will subtract it. 4p is equal to, I am subtracting first equation from the second. 4p is equal to D times of 2y minus x plus 2r. Technically, what is it trying to say? So 4p when divided by D, this information can also be written like this, isn't it? 4p when divided by D, the remainder is 2r. That's what it is trying to say. How can you represent this information alternatively? Alternatively, this information can also be written as, this is a quotient. 2y minus x is a quotient. Alternatively, this can be represented as 4p when divided by D leaves a remainder called 2r. But from the first information, how can I represent this information? P when divided by D leaves a remainder called R. Therefore, what do you know? Hey, if 4 times of the number is divided by D, I expect a remainder of 4R. But 4R has become 2R. How? Because 4R when divided by D has given me 2R. Therefore, one of the values of D should be 2R. One of the values of D should be 2R or the factor of 2R or the factor of 2R. Factor of 2R will not make sense because already R is the remainder. So you cannot write another one. Therefore, 2R is the remain. 2R is the divisor. Making sense? Clear, my friends? Everyone clear? Everyone clear? Everyone clear here? Made sense? So division algorithm, can we conclude that there is a confidence going? We can answer questions on division algorithm. All good. One part is the adjustment of these brackets. Learn to adjust these brackets. Adjust these brackets. Once you adjust these particular brackets, automatically the results come. Either you equate two equations or you subtract, add, whatever you want to do with those particular equations. Okay, good. I'm stopping the division algorithm here, going to the next concept. Give me quickly some understanding that it is good so far. So everyone is comfortable so far. Pretty simple questions, but at the same time, very critical question. Simple yet critical from exam perspective, because division algorithm is one of them which is popularly tested. Guys, other than Sonakshi, Mohit, Haider, yeah, okay, all right. Hmm. Prashant and Rishabh, okay, all right, good. One year is clear. Hmm. Fine, let's go into this question. Let's now look at the LCM kind of. Okay, think about this question for about a minute or two. Let's start by thinking. It's a simple question on LCM, right? LCM. So let's start thinking about this question. Yeah, let's think about this question. Yeah, let's think about this question. Okay, don't give me any explanation. That's okay, guys. Don't give me explanation. Think LCM of two natural numbers is 72. How many pairs, right? How many ordered pairs AB you can exist? That's all the question here, right? Co-primes, leave all that later, all that later. Okay. Fine. Listen, everybody listen. Good. All right, good. Yeah. Listen, everybody listen here. Let's close with this concept. Let's do a couple of applications based on this and close. There are many questions on LCM which will come. I'll start from here. Right. Some of the understanding. Let's start from here. See, for example, when I want 72, let us think about it. Hey, two numbers A comma B, right? Two numbers A comma B, 1 comma 72. What will be the LCM of 1 comma 72? Just to put it to perspective, what we are thinking, because we need to be clear about what we are thinking. Answer is 72. Okay, what will be the LCM of 2 comma 72? Answer is still 72, right? Answer is still 72. Hey, what would be the LCM of 8 comma 9? That is also 72. Like this I can write many cases. Finally, I can also write what is the LCM of 72 comma 72. That is also 72. Now this is what I'm asking. This is one way, this is the second way, this is the third way, like this is the nth way, right? Nth way. What is this n? That is my question, right? That is my question. So like this I can write, I can 172, 272, like this many I can. You can say that, sir, I will write 372 also, right? Whatever you want to write. The idea is, hey, like this dot 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 dot, somewhere I will write 72 comma 72. This will be the first case, second case, third case, like this will be my nth case. My point is, how many of these n cases I am writing? That is the meaning of this particular question. To understand, to start with, that is the meaning of this question, right? Okay, now in this also, the first case already now can exist once again. What is that? Okay, 1 comma 72 is different from 72 comma n. It will be already, if I write it here, can I write it as 72 comma n? Yes, this first case is different from second case. If I write it as 72 comma 1, it is different. Why? Hey, because it's a comma b, coordinates, man. A comma b are the coordinates. How many values a comma b take? Which means what? A is different from b, right? That's the coordinate. All right, therefore these values are different. A value being 72 is different from b value being 72. When I represent like this, it is talking about a coordinate. It's the order. It is also talking about order. Okay, meaning of the question is clear to everybody. I'm sure most of you would be clear with this. Just to put it to the perspective what we are thinking. Just to put it to the perspective what we are thinking. Meaning of the question is clear. Quick, my friends. Meaning of the question is clear. Answer this. Let's close it. Otherwise, we'll be simply extending till 11:15, 11:30. Quickly respond. Yeah, right. Okay. Now let's see how do we work on this. Good. Very good. Now let's see how do we work on this. First, 72. What is this 72? 2 raised to power 3 and 3 raised to power 2. Right, this is my 72, which means the highest power of 2 in 72 is 3, that is 2 power 3. Highest power of 3 is 3 power 2. Implies, now listen to this, when I have this A and B, let me only now talk from the distribution of, not distribution, let me now talk about the number of ways of dealing with this 2 power 3 in A and B. Listen to this carefully. This has a PNC also in this. This has a counting. How many? All right, now, so because LCM of this, how many, the moment counting comes, there is a PNC. There is a PNC which is coming. Fundamental principle of counting is coming into this. Numbers and PNC are coming there. Most of the parts in numbers has a PNC in it. All number of factors, odd factors, this factor, that factor. Whenever you are counting, naturally you are making use of PNC. There is no choice in the matter, right? Okay. First, let me take the first portion. What can happen with this 2 power 3? Now, this 2 power 3 can be with A. 2 power 3 is there. Therefore, B can have 2 power 0. Because when you are writing the LCM, if already A has 2 power 3, B need not have any power of 2. That is okay, because in the LCM you will automatically have 2 power 3. 2 power 3 is there. B can have 2 power 1 along with it, which means 2 power 1 have. See, addition of these two numbers need not be that. I am saying that if you want the highest power of 2 in the LCM to be 3, what are the possibilities? Possibilities are A has 2 power 3, but B has 2 power 0. There is absolutely no 2 in that. For example, I am writing 1. All right, now I am writing this case. Talk about this particular case. The value of B is 1. If the value of B is 1, 2 power 0, there is no power of 2 hidden in that. That's my point. Or it can have 2 in it, or it can have, all right, now I can continue on this. This still remains 2 power 3 and this can be 2 power 2. This remains 2 power 3 and this can also remain 2 power 3. Just like this 72, 72, when I write it, 2 power 3 can exist in both of them. All right, that's true. Okay, now coming to this, let me go further in this. Let me go further. I can reverse this. Hey, this becomes 2 power 2 and this remains 2 power 3. Somewhere on one of the two sides, there must be a 2 power 3. That is the point. Why? Because the highest power of 2 has to be 3. That's the highest power of 2. Therefore, one of the two sides, either 2 power 3 should be there in A or 2 power 3 should be there in B for sure. That is the meaning of LCM. Right? Okay, this is 2 power 1. Therefore, this remains 2 power 3. This is 2 power 0. Therefore, this remains 2 power 3. Now, these are my cases. These are my cases, what I'm talking about. How many cases? 2 power 3 therefore exist in A and B. 1, 2, 3, 4, 5, 6, 7. You are saying that there are 7 ways in which 2 power 3 can be allocated or can exist between A and B. Guys, 2 power 3 story is clear. Because when you take the LCM, 2 power 3 should be there either in A or in B. That can happen in 7 ways. Is this clear? No, in the exam you don't have to write this. Now I made it clear to you how to look at this. Then we will come to the exam way of solving it. Hey, in the exam, should I write all this? No. We will not do all that. This is not what I want to teach. Point is, let's first understand it. Let's first visualize it. Then we will see how to write it in the exam, therefore. Is this story clear of 2 power 3? Now, coming to 3 power 2, we will come to that later. 2 power 3 story is clear. Other than Rishav, Prashant, Nazia, Sonakshi, Mohit, others are understanding this, what I am talking? Is this making sense? That is how you find the LCM, isn't it? When the LCM of two numbers is 72, which means 2 power 3 should exist in one of the numbers and 3 power 2 must exist in one of the numbers. It must exist either in A or in B. Right? It must exist in one of the numbers. Now come back, deal with 2 power 3. Therefore, let's come back and deal with 2 power 3. Let's now deal with 3 power 2. Let's deal with the second piece, second portion of it, 3 power 2. How this can exist in A and B. So you may say that, hey, there is you may say that in this there is a 2 power, and in this there is a 3 power 2. If there is a 3 power 2, I can afford to have a 3 power 0 in B. If this remains 3 power 2, I can afford to have 3 power 1 here. If this remains 3 power 2, I can afford to have 3 power 2 here as well. Both sides it can be 3 power 2. Then the matrix can reverse as well. Hey, this continues to be 3 power 2. This can be 3 power 1. This can be 3 power 2. This can be 3 power 0. Therefore, you say that, hey, 3 power 2 can exist in both of them in 5 ways. This can happen in 5 ways. 1, 2, 3, 4, 5. This can happen in 5 ways. Now what? Combination of both of them, 3 into 5. Therefore, there are 35 ways to the combination, because I need to allocate my 2 power 3. I need to understand the ways of allocating 2 power 3 and fundamental principle of counting. This is activity 1. What is activity 1? Trying to deal with 2 power 3 is activity 1, and you got to deal with your activity 2 as well. What is your activity 2? Trying to deal with 3 power 2. That's your activity 2. Therefore, how many ways you can deal with 2 power 3? You said that 7 ways. And means what? Fundamental principle of counting, independency. Therefore, into how many ways you can deal with 3 power 2? This can be dealt in 5 ways. You found out here 7 ways and 5 ways. Therefore, together you can deal it in 35 ways. Therefore, there are 35 ways of allocating this particular number. A little bit of PNC plays a role here. Understood? Everybody understood? Everybody understood? I can write some sample cases out of 35 cases. These are some sample cases what we wrote here. These are some of the sample cases. Clear, my friends? Clear? Is this clear? You need further explanation, or did you understand this? Do you understand this? Okay, you don't have to write so much in the exam. But yes, to bring a clarity, I wrote all of this story. I hope this story is clear. Right? 35 is the answer, in fact. 35 is the answer to this particular question. Okay, how do I put it to the perspective, knowing little bit about PNC? Therefore, I say that, hey, you got to know the basics of all the chapters. Right? Basics of all the chapters you should know. Otherwise, sometimes you may be damn good at numbers, and simple question on LCM, not simple, okay, intermediate level question at LCM can trouble, because kind of counting algorithms are not in place. Once the counting algorithms are in place, there's no big deal about it. Okay, how do I do this? How do I do this? Mathematically, if I'm doing it, now having understood there is a counting algorithm involved here, total minus none, total ways of allocating this 2 power 3 minus the things which are not in my favor. So what is that? Now let me write this. Let me take this 2 power 3 story. I will write this. 72 is nothing but 2 power 3 and 3 power 2. Listen carefully. I am looking at this 2 power 3. Now there are two fellows A and B. There are two fellows A and B. So now you say that, hey, there could be 2 power 0, 2 power 0, maximum is 2 power 3. 2 power 1, B can also have 2 power 1, C can have 2 power 2, B can also have 2 power 2. This is 2 power 3 and this is 2 power 3. But I know that at least either A should have 2 power 3 or B should have 2 power 3. That much I know. Okay, but the point is, totally how many ways here? A can take any of the 4 values. B can take any of the 4 values. 4 into 4, 16 values. 4 into 4, 16 values. However, if this 2 power 3 is not there in one of them, in both of them, in both the cases 2 power 3 is not there, then they are not in your favor. What is this to 16? This is total. What is not in my favor? This portion. If A has either 2 power 0 or 2 power 1 or 2 power 2, 3 cases, which means this is 3 cases. Now B has either 2 power 0, 2 power 1 or 2 power 3, 3 cases. If the highest power of B is either 2 power 0, 2 power 1, 2 power 2, similarly highest power of A is 2 power 0, 2 power 1, 2 power 2, then the LCM cannot be 72. You will not get this 2 power 3. Reduce these cases. 3 into 3, 9. What are these? These are unfavorable cases. Total minus unfavorable cases or the favorable cases. How many cases are favorable? 16 minus 9, 7 cases are favorable. This is how you represent this thought in math. You don't write this whole story. Instead of writing this full story, this is what you write. Hey, you may say after some time that I don't even want to write it, sir. There is a 2 power 3 here. I can look at this 2 power 3. After some practice, when you look at 2 power 3, number of factors 4, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 3, 4 factors. Therefore, simply make it 4 square. Remove one, last of them, 2 power 3. Count up to 2 power 2. That is 2 power 0, 2 power 1, 2 power 2. Count up to there. Minus 3 square. What is 4 square? minus 3 square, 7. When you look at this 2 power 3, you can directly write this as 7. This is the way of dealing with this. No, I still want to write little bit to get that clarity because I'm little confused in the exam. I'm little more cautious in the exam. Write at least this much. That is good enough, right? That's how you get that 7. I will do for this 3 power 2 also. Try and observe this. What do I do for 3 power 2? When I'm trying to allocate between A and B, allocation, some A can be 3 power 0, but the point is at that point in time, B should be 3 power 2. The point is, okay, what all values A can take? 3 power 0 it can take, 3 power 1 it can take, 3 power 2 it can take. Similarly, B can also take 3 power 0, 3 power 1, 3 power 2. But the point is, when B is taking 3 power 0, A is supposed to be taking 3 power 2, right? Yeah. When A is taking 3 power 1, B is supposed to be taking 3 power 2. That is the point there. But the point is, what is the total, man? A can take any of the 3 values, correct? B can take any of the 3 values, correct? Totally, it can take 9 values. But if one of them is not considered in 3 power 2, had A been taking any of the first 2 values and B also been simultaneously taking any of the first 2 values, then it will fail. Then the highest power of 3 will not be 2. Then it fails. 2 minus 2, 4. Therefore, it is 5 base. This is the 5 what you wrote here. Comfortable? Understood the concept? Understood the concept? Understood? Hmm. Understood? Right? 35 is the answer, right? Good. All right. Fine. You solve this. Then we are done. Yeah. Solve this question. Read question carefully and get the right answer. Read the question carefully. In a minute, give me the right answer. Yeah. Take a minute and get the right answer. Whoever understood the last question, you should be able to give me the right answer. Quickly. Push yours. Hmm. Guys, those who are attending my algebra lectures, I told you you need to be very, very careful with certain variables or questions, etc. Right? We are doing algebra on the special class, right? Free special class. So when we are doing the free special class algebra, I told you all it now the same equations. We were doing integral solutions, etc., etc. We were doing that. I asked you, I cautioned you to be very, very careful with it. Now listen to this. Unlike earlier question, so it is a pair. All right, when you write a pair, let's say that okay, I have two values, 1 comma 45. Is this pair same as 45 comma 1? Is this pair same as 45 comma 1? Yes. Yes. Right? Yes. LCM of 1 comma 45 is also 45. LCM of 45 comma 1 is also 45. When I use the pair, order does not matter. You need to be very careful while reading the question. It can be the same concept, but the presentation matters, right? It can be the same concept, but it is always about the presentation, right? How the presentation is done, right? The presentation matters on this. All right. Yeah. Let's take a look at this. So therefore, if the presentation is misunderstood, you will get the wrong answer. Presentation is clear, you will get the right answer. Therefore, I say, hey, don't be in a hurry. Read question carefully. Concept remains same. Now you are revising your answers. They are right now. Now what you are trying to revise is making a little bit of sense. Right? Yeah. Okay. Let's take a look here. Aradhya, I think you are not, you follow the protocols here. Don't keep typing whatever comes to your mind in between. Wait, let's finish the class. Then you type all of that. When we are doing the class, let me focus. You also focus. Right? Yeah, you also focus. Don't take a suggestive tone, this, that, all of that while doing the lectures. Right? In between, you are taking a suggestive tone saying that I understood, carry on. I'm also bothered about others, not just you. Right? Yeah. So I know where to stop. I know when. All right, don't be suggestive. or trying to ask something here and there. Hang on. If you have watched my previous videos, you will understand the kind of protocols that we follow, right? So we are not here like, like a football throwing some information there, trying to discuss that information. Somebody throws another football, we will kick it somewhere there. Hey, that's not the way to learn, right? There is a systematic way to learn. Towards the end, you wait your concerns, we will put it across till some concerns, put it in the Telegram group. I will answer, or somebody who is there in the Telegram group can understand it, they will answer, somebody will get back to you. Don't worry, right? Yeah, don't create a food, or don't create the chart as one football field, right? Everybody trying to kick it here and there without any direction. That's not the way we are trying to deal here on Cat Ninjas, at least, right? Yeah. So let's all, I hope all it, no, so we all kind of follow that protocol so that the discussion appears to be healthy and it looks direction, right? That's my whole point. Fair enough. Okay, no offenses meant to anyone. It's not only the message to Aradhya, it is message to everybody for that matter. Just in case, all right. Just in case, all right. If you are not following certain protocols, that's the point there. Okay, yeah. How many pairs of numbers can be formed whose LCM is 45? Yes, what you numbers you got in the beginning are right, and some of you tried to revise the numbers. They are correct now. They are correct now. Very good. Yeah, 45 is nothing but 9 into, right, 3 power 2 into 5 power 1. Just in case you want to understand, once again, this 3 power 2, you kind of write it as 3 power 0, 3 power 1 and 3 power 2. There may be two variables. You can say that, hey, to start with, I will give two names here, 3 power 0, 3 power 1, 3 power 2. You would say that this is 3 into 3, together it is 9, and then you say that these are not in my favor, 2 into 2 are not in my favor, and hence you say that 5 base. All right, similarly, you take a look at this 5 power 1. All right, you look at this 5 power 1 and you try to distribute between A and B. So you would say that 5 power 0, 5 power 1, 5 power 0, 5 power 1. You say, hey, this is 2 into 2. Exhaustive is 4 ways, not in my favor, or 5 power zeros. Therefore, you say that is 1 into 1, which is one way. 4 minus 1, it is 3. And you all multiplied this 5 into 3, which is 15. That's correct. All right, 15 is correct, provided there is a nomenclature A, B kind of. However, out of these 15 cases, remember, there will be a duplication. There will be half of the cases in which A would be greater than B. There would be half of cases in which A would be greater than A. And there would be half cases in which A will be equal to B. And hence you say that, hey, 7 cases would be here, 7 cases would be here, and 1 case would be here. And hence your answer is 7 plus 1. These two 7s are redundant. This 7 I can discard. Either I can consider one side, discard the other side. 7 plus 1, 8 becomes my answer. Just in case if you want to understand, had there been A and B, you might have written 1 comma 45. You might have written 3 comma 45 so that the LCM remains there. Likewise, already you might have written somewhere there as 3 comma 9 comma 5 also. This is also fine. All these are fine. But likewise, you would have gone and you might have written it as 45 comma 45. Then you might have considered reversing this as well. 45 comma 1. I'm saying that discard this. I don't want this, discard this. These 7 cases can be discarded, hence answer becomes 8. Good guys, learnings are clear. Learnings are clear. All good. You understood this matrix. Did you understand? After understanding this question, it is not ordered pairs. This pairs relates to this particular matrix. Is this clear? Has this chart given you the clarity what we are talking? Has this given the clarity what we are talking? Yes, no, right? All of you quickly respond. We're done. We're done. Right? Yeah. Nice. Okay. Did you all learn something? Did you all learn something? Okay, this is your time. You guys want to type something, say something, present something, you can do that. All right, you can do that. This is the time. Okay, if anybody has not liked it, okay, you can, if you have really liked it, then put it as a like. There is no force to like or something. But if you have liked it, already for the bottom, if you feel that yes, it made a difference, understood something, always like, and you can share it with somebody else as well. So if anybody is preparing and you know they would like to prepare, you can do it to them. Yes, and coming to the tomorrow's lecture, tomorrow we'll be doing it one special class that is 4:30 to 5:30. Most likely, in all likelihood, we'll be doing this. We'll be doing on the modulus mods. Mod, all right? Mod is what we are going to understand. Linear mod, especially the linear mod, the way to deal with maxima, minima on the linear mod, etc. That's what we will do on the in the special class, which is technically done on the Unacademy app. Right, we are doing it on the Unacademy app. not downloaded, download the app. While using it, if there is an introduction code or referral code required, you can use my referral code to download that particular app. This is what we are doing tomorrow. And yes, on tomorrow, so I think I completed PNC most of it today. So little bit is left. Tomorrow we'll be starting probability. If anybody is on the Plus platform, you can attend this probability lectures on tomorrow and day after. Right, that's briefly about this. And somebody wants to, all right, now you want your doubts or something to be clarified or brief counseling, something is required, you can join this Telegram group. All right, not just that you have to type in here itself. So you can also join the Telegram group. Listening offline, so you can also still join and you can put it out there. And you want to put some comments, you can put post comments column would be there. You can comment there. So if there is something that I need to come back and respond, certainly I will respond. Okay, all right. So what is that, Anurag, you are saying? If asked order pair, then the answer is 15. That's correct. Anurag, answer to your question is correct. If it is the ordered pair, your answer is right. Okay, yeah. One year I will see based on the time available. So it's all directly proportional to time. So based on how much time is available, sure, I will try and do. Sonakshi, every month I'll be doing about 2 courses on Plus, right? 2 short courses. I'll be doing it on Plus. Okay, how many courses on Plus? About two courses, 2 short courses, just like what we are doing here. All right. So any other questions, you can put it here. Otherwise, I think we will close it. Right, all right, hey, pretty much all it. So I appreciate you guys coming day after day. That's very nice, right? Very appreciative. Nobody forces you to come in here, but still, most of you watch it offline or online. It's very nice to see you guys online out here. Pretty appreciative of you guys, because probably I might not have the kind of commitment you guys have. Honestly, I might not have these kind of commitments unless there is some pressure. Then you guys have amazing commitment. Nice. Very glad to see you guys day after day. See you guys tomorrow. So at about 4:30 on the app. So I will see you there. Bye till then. Good night. Stay blessed. God bless you.